This is example 3 of the Rational Functions Part 2 lab. We have the following function. We want to find some attributes of this function, such as horizontal asymptotes, oblique asymptotes, vertical asymptotes, or holes, if it has any of the above. So it's already been factored for us into this form right here, and we can easily identify if it has any holes or vertical asymptotes. Because there are no factors that cancel, we know that it has no holes. So for holes, we have not anything. Vertical asymptotes appear when the denominator is equal to 0. So if x minus 4 is equal to 0, then at x equals 4, there's a vertical asymptote. So there's a vertical asymptote at x equals 4. For horizontal or oblique asymptotes, we have to look at the degrees of the numerator and the denominator, respectively. So the degree of the numerator is the leading exponent of the variable. So here the variable is x, and the leading exponent, the highest exponent, is 2. So the numerator is of degree 2. And the denominator, the leading exponent here, is this invisible 1 right here. So we have a degree where the numerator is larger than the denominator by exactly 1. So the rule is that if the degree of the numerator is greater than the degree of the denominator by exactly 1, then we have an oblique asymptote. And the way we find that asymptote is we actually need to divide this by long division. So we're going to divide the numerator by the denominator through long division. So here I've written that out. We have the numerator here and the denominator here. We're going to follow through with this division to find the oblique asymptote. So when we do long division, we take this leading number right here, this x, and we look and we go, what do we multiply this number here, this x, by to get this number right here? So to get 3x squared from x, we need to multiply this x by 3x, and we're going to write that number up here. So we have this 3x, we're going to multiply this 3x by this x, which will give us our 3x squared. And then we're going to multiply this number by this negative 4, which is going to be negative 12x. So we have this number right here. We're going to subtract all of it. So we have 3x squared minus 3x squared. So our 3x squared will cancel. This negative goes over here to make this 12 positive. So we have negative 14x plus 12x, which will be negative 2x. And then we're going to bring down our negative 5 down here. So the first step is done. We need to continue on until we have nothing left. So we have a negative 2x. We have the x here. What can we multiply this x by to get this negative 2x? We can multiply this x by negative 2 to get this negative 2x. So we put negative 2 up here. We take this negative 2, we multiply it by this x right here, so we get negative 2x. We take the negative 2 and multiply it by this negative 4, so we get positive 8. We subtract all of it. So we have negative 2x plus 2x, because this negative distributes. So the negative 2x's cancel. We have negative 5 minus 8, which is negative 13. Now there's nothing we can multiply this x by to get negative 13, because negative 13 does not have any x's. And so this is just going to be a remainder. And we're left with this number here, this 3x minus 2. And that is our oblique asymptote. So if we have 3x minus 2, we can rewrite that as y equals 3x minus 2, and this will be our oblique asymptote. An oblique asymptote is essentially an asymptote that is a line. It's a linear asymptote. So we have a oblique asymptote at y equals 3x minus 2, and we have no horizontal asymptote.